Hello students, next we'll start 3D shearing. Already we have seen the concept of shearing, that is in 2D. Now we'll discuss about 3D shearing. Okay, now we'll see the 3D shearing is nothing but shearing with respect to 3D. So here, as we have already seen, you have already seen this concept in Zoom class, that is 2D shearing. Mainly we require that under shearing we require some shearing factors. Those shearing factors are shear X. Initially we will be having shear X, and one more we will be having, that is shear Y. That is in 2D, because we were having only two axes, that is X axis and Y axis. With respect to those axes we will be having shearing factors. But now here 3D shearing, because of it is 3D shearing, here we have to use that three factors, that is SHX, SHY and SHZ. Three factors we are using. Where we have to use, how we have to use, how we can consider this, that we'll see now in the coming classes. Now what we have to, how we have to consider this, we'll suppose generally I'll explain you, I'll highlight that how to use this. See, if the concept is z-axis, with respect to z-axis means you must shear X and Y. If you want to shear X, we have to use shearing factor SHX with respect to Z. Means on Z axis we have to use this SHX. Means that towards Z axis you are going to shear that X. Then if it is Y, then SHY we have to use with respect to Z. Okay, now we have to write the formula with respect to this, and with respect to formula what matrix we have to, will get, that we have to consider. So continuation of this, if it is Y axis, what we have to use here, if it is on Y axis means remaining two must be considered, that is X and Z. Here with respect to X we use the shearing factor SHX. If it is with respect to Z, we use the shearing factor Z, SHZ, and this is with respect to on Y axis, this is with respect to on Y axis. So what will be that Y now? Y will be constant. Here Z will be constant. Here Z will be constant. So in the same way, here again we have X axis. What we have in X axis? With respect to X axis, other two, what we have, that is Z and Y, shearing factors will be SH, Y, because of this is on Y axis, and this is SHZ, but axis is X. Axis will be same, but shearing factors with respect to which you are using. So X axis means this will be constant. X will be constant. Okay, now we'll continue with respect to an axis, how that shearing happen. Now shear X. Okay, we'll consider first shear Z. So in shear Z, what all other two will be having now? So other two are SHX and SHY will be the shearing factors, and Z will be constant. So for this, the formula, and with respect to this, what all the matrix we have, that we have to discuss now. So under this, what we have, the shearing factors, SHX is one factor and other one is SHY. These two are the factors we have to use, and Z will be constant. This is constant. Why we have to keep this as constant? We are not changing that Z, we are shearing X and Y with respect to Z axis. So what will be the common formula and also factors we have? Z will be Z, same, and X dash we have to calculate what will be there and how we will get from the matrix, that we have to see. So already we have seen from the formula, this first factor will be X will be there, X plus what we have to do, Z dot on Z axis we are shearing, that is SHX we have to use as a shearing factor. This is a shear factor with respect to X. Then Y dash is Y plus Z dot SHY. 1. This will be the shear factor. Shear factor with respect to y will be SHY, with respect to x will be SHX, but the axis will be same. Axis is Z axis. Okay, so for this we have to use a matrix. That matrix will be considered as x dash, y dash, z dash. We have this x dash, y dash, z dash. Here, as we know, we have the matrix including that homogeneous. Without homogeneous, first we have to write, then we have to convert that into one homogeneous. Initially this x is there and y is 0, the other one is 0, but on z axis with respect to x we have. So here we keep this as an SHX. Understood why we took SHX over here? Because we are with respect to z we are shearing. So on z axis we have to write with respect to x and also by considering z. This is 0, 1 and SHY, shear y on z axis. Then this is 0, 0, 1. Okay, what we have to write? What else is left? Here we have to write x, y, z. From this formula, this matrix will get. Actually, if you multiply this matrix, you will get that formula back. Okay, now we'll see that how we'll get that formula from this matrix. What is the matrix given? If you want to get this new values, we have to use this matrix multiplication concept. So 1 into x, what we'll get? 1 multiplied with x, then plus 0 multiplied with y plus SHX multiplied by z. Okay, second one 0 multiplied with x plus 1 multiplied with y plus SHY multiplied with z. Next 0 multiplied with x plus 0 multiplied with y, 1 multiplied with z. What you will get in this? We'll add this and we'll continue. What we have to do? What you will get here? This is x plus 0 plus SHX dot z will get. Okay. So next one 0 plus y plus SHY dot z. Here 0 plus 0 plus 1 will get. So what is the output? X, the 0 will be neglected, plus SHX dot z. Y plus SHY dot z. 0 plus 1. So that is nothing but z dash is nothing but z. 0 plus 1 means that 1 is nothing but that is not 1, that is z actually. Okay, so finally we will get z. This is what we'll get, we have got from this matrix. So here by this what we can understand, just I'll overview this. Shear z on z axis, if you want to shear with respect to z axis, we need to consider x and y. So the shearing factors with respect to z axis is SHX and SHY. So for that z will be constant, no changes on z, only the changes with respect to this x dash and y dash. For x dash the shear factor is SHX, for y dash shear factor is SHY. So with respect to this, we will get a formula like this to shear and to get the new values. So for that the matrix, see whatever 3D or whatever the graphical representation if you are doing, all this which comes from the matrix only. So with respect to matrix you can substitute like this. So in a matrix x dash, y dash, z dash are new values, x, y, z are old values. Okay, so x dash, y dash, z dash new values we have to get from this concept. So what we have, this is an homogeneous matrix. In this homogeneous matrix or orthogonal matrix, here we have to consider 1, 0, SHX. Why we took SHX and SHY over here? Because of with respect to Z shear we are doing. So SHX and SHY on Z axis. 1, 0, instead of 0 we have to use shear factor. We are shearing X with respect to Z. and 0 1 SHY. With respect to Z, you are sharing Y. Then 0 0 1, no shear on Z. So this is what with respect to Z. Same thing we have to apply for even Y and X. Okay, we'll continue with shearing. Now I am shearing, shear. Now we'll do Y shear. Shear Y. Shear Y. If you want to shear Y, what we have to consider? We need to consider two shearing factors. Those two are here, SHX and SHZ, and Y will be constant. Y will be constant. With respect to this, we will take a formula. Y dash is equal to Y. Then X dash is equal to X will be there. You are shearing with respect to Y, and so consider Y. Then the shear factor is shear X. You are shearing X. Then Z dash is equal to Z plus Y dot SHZ. Okay. Now we'll consider with respect to matrix. With respect to matrix, here on Y axis we need to do the changes, and remaining will be same. 1, okay, 0 0. Usually the matrix will be like this, right? The matrix will be like this, but here what will happen here? We are going to change this Y axis, because on Y axis you are applying shearing with respect to X and Z. So X will be replaced by SHX and Z will be replaced by SHZ. Okay, if you apply, so before applying that, here with respect to old values X, Y and Z. Okay, if you apply matrix multiplication, what you will get? You will get that exact formula before this matrix what you have. That is X multiply with X, you will get X. Y multiply with Y dot SHX plus 0. Then second term 0 plus Y plus 0. Then 0 plus Y dot SHZ plus Z. This will be the result. We'll neglect zeros. So you'll get X plus Y dot SHX Y dot SHZ plus Z. You'll get the formula like this. Once we get the formula, once we find out that formula, then by using this formula you can continue with the calculating shearing sheared diagram or an object once it shear applies. So on XY means like XY with respect to the Z means it towards Z it shears. If it is Y means towards Y it shears. Now we need to continue with shear X. Shear X means with respect to X axis. So what all shear factors we have to consider? Shear Y, then shear Z. X will be constant. With respect to this, what all we have to consider? X dash is equal to X, Y dash is equal to Y plus shear factor is SHY with respect to X axis. Z dash is equal to Z plus SHZ dot what? X axis. Okay, so now we have to consider the matrix X dash, Y dash, Z dash we have to use. Consider the matrix. Which portion of diagram will change now? The portion which is on X axis will be changed. So usually we will be having 1 0 0 0 1 0 0 0 1, but this portion will be changed now. What changes you will expect here? This portion with respect to this, what will be? 1 will be there because X is constant. Then in place of Y, SHY we have to write. In place of Z, SHZ we have to write. Okay, then remaining will be same 0 0 1 0 and 0 1. This will be same. So this is what will happen for all the concepts and for wherever you are going to explain. So this will be multiplied. Okay, in the previous X shear portion we have considered the matrix. This matrix must be multiplied with x, y and z. Once you multiply, you'll get that above portion. Above portion what we have, that is x dash is equal to x we have, and y dash is equal to y plus shy dot x, and same thing you will get if you multiply this with these concepts. This completes shearing. So based on this and by using this concepts, we can shear an object however we want.